So I talked about in the previous slide the accounts, and here I'm going to actually look at some of the code. So I've got the workshop repo opened up. This is the one that I linked you guys to. We're in the beginner crash course workshop, of course. And if you head into the client examples, we basically have a number of TypeScript scripts. And so you can see here, like there's some util stuff. So like the one thing I want to call out is you want to have Solana installed to run these locally because this is what's going to load your local wallet key pair. And that's going to be designed to pay for transactions, which we'll talk about in a minute. And then this log file is just a bunch of print statements. You don't really have to worry about it. And then transaction, we're going to cover this in a minute. This is how you build a transaction. So I will come back to this. But first things first, if you look at the account script, this is where we actually are going to create a new key pair, right? So we're going to use this key pair.generate to create a new key pair. But like I said, that public key has to be registered with the Solana network first before it can be activated as an account. So like you can create key pairs all you want. It's just a default library for creating key pairs. I don't exactly remember which specific library it is, but it's just like creating a new SSH key pair. Like it's not going to do anything until you put it into some kind of like place where it's going to be used. But you can still create key pairs all you want. So we're going to generate this key pair here. And then, we'll talk about the transactions because the first thing we're going to see is how you actually go ahead and create an account, which is going to be registering that new key pair's public key with Solana. So going back to transactions here, I just want to talk quickly about how you interact with the Solana network, and then we'll step through all that code. So the first thing is you use RPC requests to communicate with the Solana network. If you guys are familiar with HTTP requests, it's pretty similar. There's some notable differences, but when you're writing code, you honestly won't necessarily notice too much of a difference until you get into real complex builds. So you can think about it just like a GET or a POST request. So if you think about a GET request, you're going to make an RPC request to the Solana network and ask for some information. And that's going to be like a query. So if you wanted to look up like, what is my current SOL balance? You would make an RPC request to the network and it would return to you a response with whatever it is you've asked for. In this case, your SOL balance. If you want to change data on the Solana blockchain, equivalent to a POST request, what you actually have to do is you actually have to send an RPC request with a transaction. Now I'm going to quickly check the questions and then I'll cover transactions. Is it possible to layer dApps under pre-existing apps? Yeah, so we can circle back to this later, but yeah, what you could do is you can basically integrate applications that are Web3, so like that are interacting with the blockchain, into your own app. Like one example is like if you had a microservice architecture, if you guys know what that is, you could have your app running and then it could just communicate with your dApp. But what you'll see in this workshop is that dApps don't live on chain. The only part that lives on chain is your smart contract. So without confusing people, what you want to do, I think, is totally possible, and we can come back to that later. But yeah. So anyway, I'm going to continue with transactions so we can start covering some of this code. So transaction is just really like a message payload that you're going to send, which is why I said it's like similar to a POST request, because it's a prefabbed payload that is designed to communicate with the Solana network. The network is designed to receive these, and they follow a very specific format, which you're going to see on screen here. So on the left, we have a transaction. So the transaction has a list of signatures and then a message. And the list of signatures are just hashed versions of that transactions, hashed by your private key. So we talked about signing earlier. Those are just signed transactions. And you actually, like, the network is going to take a look at those, and depending on what program you send the instructions to, blah, 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 it's going to make sure those signatures are valid. So we can ignore the header field. Oops. We can ignore the header field for now. The addresses field is going to be a list of public keys that are associated with this particular transaction. And then the instructions list is going to be a list of instructions, which are on the right. We'll talk about in a sec. I just want to quickly call out that every transaction uses this field called recent block hash. And what that basically means is when you go to send a transaction, it's required that you query the network and you get a very recent block hash. Most people just get the latest one, like the current one. And that's just the current hash that the blockchain is on. And the reason that Solana does this is because it's going to key on that block hash and make sure that not too much time has passed. So this helps prevent like fraud and like kind of like hacking maneuvers. Because if this is a really old transaction, like A, you might not want it to go through anymore, and B, it could be malicious. There's a lot to that, but the point is it's a security measure. So when you create a transaction, you'll have to do that. And then in the instructions, you can see here, each instruction is pointing to a specific program using its address. Again, because smart contracts are accounts, they all have public keys, which are blockchain addresses. So you tell the instruction which program this is for. And then the accounts are, again, a list of all of the accounts that are needed for this instruction. So you can see that addresses and accounts are present in both payloads. It might seem a little redundant, but basically you include all of the addresses for the transaction because it's validated on chain and it's used to, figure out parallel processing. And then you also include them in the instructions because you can include multiple instructions in a transaction. So let's say you need like 5 addresses for one instruction and 3 for another. And let's say they're all different. You would put all 8 in the transaction, but you only need to include in the instructions which ones are for which. So that's why it's present in both spots. And a quick note on parallel processing. Solana actually makes use of parallel processing of state changes, just like a database would, which is one of the reasons why it's so fast. So the reason you're looking at this structure here, and the reason it's so strict is because what's happening under the hood is the runtime is basically going to look at the different accounts that you mean to change or use, and it's going to check to see if you're reading or writing. If you're reading, you can do all those reads in parallel, right? Because they're not changing. If you're writing, then it's going to lock them. And so with this mechanism, Solana is allowed to process state and instructions that are mostly either just reading or writing or whatever in parallel for the most part, right? With the obvious exceptions being any kind of lock conflicts. So pretty cool stuff. And the last bit for the instructions is the instruction data. That, just like an account's data, is represented in bytes. And we'll see what that looks like later. But that's going to basically tell the program what to do. So you send an instruction to a program, and then one program might be capable of like a bunch of different program instructions. So like, for example, the system program, it can create accounts, it can allocate space, it can do all these different things. And you would send the instruction with the proper data to tell it which operation to do.